We can generalize the specific example that we just worked through. We want to, in general, find the equation of a straight line through the point x naught, y naught, z naught in the direction of a vector v equals ai plus bj plus ck. Now, we picture this the same as before. We let this point represent x naught, y naught, z naught, and we let this vector represent our vector v. And out here we let some point represent x, y, z. We construct a vector from our point to the point x, y, z and express the condition that this vector be parallel to v. Now this vector is what? Well, this vector is x minus x naught I plus y minus y naught j plus z minus z naught k. And that vector, we can say x, y, z is on the line if and only if this vector is a multiple of v. Okay, so for some constant t, we have this equation. Now, that equation, if we write it out, becomes x minus x naught I plus y minus y naught j plus z minus z naught k equals t times ai plus bj plus ck. And if we multiply this out, we find that the I component on this side is x minus x naught, the I component on this side is TA. So we get x minus x naught equals TA, y minus y naught equals TB, z minus z naught equals TC. And if we solve the equations for x, y, and z, we get our parametric equations. Parametric equations, x equals x naught plus TA, y equals y naught plus TB, z equals z naught plus TC. These are parametric equations. As before, we can solve for t. We get t equals x minus x naught over a, t equals y minus y naught over b, t equals z minus z naught over c, so that our symmetric equations can be written by setting these three expressions, which are all equal to t, equal to one another, and we get x minus x naught over a, bad looking x there, we'll have to live with it, y minus y naught over b, z minus z naught over c. These three equal. Once more, these conditions, this condition that x, y, z is in the line if and only if these vectors are parallel, this condition that the two sides of the equation are equal, these three conditions which are equivalent to saying that the two sides of the equation are equal, the parametric equations that we get by solving these equations for x, y, and z, giving us three equations, and the symmetric equations that we get by solving the parametric equations for t and setting them equal. These are all equivalent, and I'm not going to draw it because it gets a little messy as it did before, but if we start from this point and let t take all values, then we're going to get vectors that lie along this line, and we'll get all vectors that lie along this line. If t takes all values from negative infinity to infinity, negative numbers, of course, taking us this way, positive numbers taking us this way, we get all the points that lie on this line.